This is Introduction to Mechanics review video number 2. Feel free to stop these videos at any time and work these problems on your own without me jabbering in your ear about them. So here we have the momentum of a 3 kilogram mass varying according to this equation, and we want to know the mass's acceleration at a time of 2 seconds. To find the acceleration, it's helpful if we have the force. Since we have the mass, if we had the force, then we could find the acceleration. Well, we remember that the force is the time derivative of momentum. So that means that the force equation is going to be the derivative of that equation at the top of the screen, which is going to be 6t in the I hat direction, or in the positive x direction, minus 9 in the y direction, because j hat refers to the y direction, k hat refers to the z direction. Well, when we differentiate that, we just get 0. So if we put 2 in there, 2 seconds, because that's the time we're asked about, we get 12 newtons in the I hat direction minus 9 newtons in the j hat direction. And that's going to give us, isn't it, a net force. This is a 3, 4, 5 right triangle of 15 newtons. 9, 12, 15, 3, 4, 5. So the net force has a magnitude of 15 newtons. According to Newton's second law, the net force is equal to the mass times the acceleration. So if the net force is 12 I hat minus 9 j hat, then the acceleration is going to be 12 I hat minus 9 j hat divided by 3 kilograms. In unit vector form, the acceleration is going to be 4 I hat minus 3 j hat, and then the unit, of course, will be meters per second squared. And then it also says find simply the magnitude of the acceleration. Well, the magnitude of the acceleration is going to be a net force of 15 divided by 3 kilograms, so that's 5. So the only difference between these two boxed-in answers is that the one on the left gives you the components in this case, positive x direction and negative y direction, and the one on the right is the overall acceleration, 5 meters per second squared. Let's try one more for this video. Here we've got the potential energy of a 5 kilogram mass, and it varies with position according to that. And at position 3 meters, we want to know the magnitude of the acceleration. So once again, if we have the mass and we want acceleration, it'd be nice if we had force. Well, the force we went through in an earlier video is du dx, changed sign. So first, let's differentiate this with respect to x. If we just differentiate that, we're going to get 9x squared minus 7x minus 10. Now that's just taking the derivative, but we need to take the opposite of that. So I need to change the signs of all these. Change that to negative, change that to positive, change that to positive. So at a position of x equals 3 meters, we put a 3 in here. What does this come out to be? This one will be negative 81, and that one will be 21, and that's just 10. What does that give us? That gives us a force of negative 50 newtons, which just means it's pointing in a direction that's not what we said was a positive direction. Well, if we have the magnitude of the force being 50, and we have the mass being 5, then according to Newton's second law, the magnitude of the force is 50, the mass is 5, so what's the acceleration? It looks to me like the magnitude of the acceleration is going to be 10 meters per second squared.